Okay, next we have voltage tripler. As the name indicate, the output voltage will be 3 times the peak value of the voltage on the secondary coil. Like we have this V output, the output voltage we will get will be 3 times the peak value of the input voltage, 3 Vm. We have to prove this now. Now this is the circuit diagram of voltage tripler. We have 3 diodes and 3 capacitors. This is capacitor C1, this is C2, this is capacitor C3. This is diode D1, this is diode D2, and this is diode D3. Now during the first positive half cycle, this chain will become positive, this will become negative. So it means that this diode D1 is forward bias. I act like a, and diode D3 is also forward bias. And both of them act like a short circuit, while diode D2 is reverse bias, and this diode act like a open circuit. Now here I will replot this figure again. This is during the positive half cycle, first positive half cycle. This is C1, and here we have this diode D1 which is forward bias, so it means that there is a connection between these 2 points. And here we have capacitor C2, and here we have diode D2 which is reverse bias, so it looks like an open circuit, so there is no connection between these 2 points. And here again we have capacitor C3, and here we have diode D3 which is open forward bias, so it acts like an open it acts like a short circuit. Now during this capacitor C1 charged through diode D1. This is D1, this is D2, and this is D3. While capacitor C3 cannot be charged because C2 is not charged. C2 is uncharged. And we know that C2 charged first, then C3, because C2 comes first, then C3. So first C2 will be charged, and after that C3 will be charged. C2 cannot charge because this circuit is open, so it means that C3 cannot be charged also. So only C1 charge in this first positive half cycle, and this C1 charge through diode D1. Now this is positive, this is negative, so this will be positive, this will be negative. So it means that the current will flow from positive to negative direction, so we have this loop. Now apply Kirchhoff law to this loop. Now once this C1 charged to its peak value, then the potential or the voltage through this capacitor C1, I call it VC1. Now we start from this end and we goes like this, so we are moving from negative to positive. So we have here we have the voltage which is Vm, so we have Vm, and then we reached from here we are moving from positive to negative, so it will be minus VC1 which is equal to 0. So VC1 is equal to Vm. So it means that this capacitor C1 charged to its maximum value, and the voltage through this capacitor is VC1 which is equal to Vm. Now during the next negative half cycle, in the first negative half cycle, what will be the situation? We will see it here. We have capacitor, diode D1, we have capacitor C2, then we have diode D2, then we have capacitor C3, and we have diode D3. Now during the first negative half cycle, the polarity of this point secondary coil changes. This now become negative and this now become positive. This end become positive. So diode D1 and D3 both are reverse bias. These are reverse biased. This one also, and this will become forward bias. So diode D1 and D3 act like a short circuit, open circuit, and diode D2 act like a open circuit. Now we will replot this figure again. So here we have capacitor C1 and its voltage is VC1, which is Vm, and here we have diode D1, which is open, and here we have capacitor C2, and here we have diode D2, which act like a short circuit, and here we have capacitor C3, and here we have diode D3, which act like a open circuit. This is diode D1, this is diode D2, and this is diode D3. Now during this negative half cycle, this capacitor C1 cannot discharge because we have this path is open. So, and also this capacitor C3 also does not charge because this path is open. So only this capacitor C2 charge during this negative half cycle and is charged through this diode D2. Now this is negative, this is positive. So this will be positive and this will be negative, and the current will flow in this way. Here we have the voltage, which is Vm between these two ends. Now applying Kirchhoff law to this loop, we have, I am starting from this point, So we are moving from negative to positive, from lower to higher. So here we have plus Vm. And then we reach to here, we are moving from positive to negative, like from higher to lower. And here the voltage through this capacitor, I call it Vc2. So we have minus Vc2. And then again I reached here, and this will become, this is now positive, this will be negative. So we are moving from lower to higher. So this will be plus Vm, which is equal to 0. So Vc2 will be equal to 2Vm. So the capacitor C2 charged through diode D2 to its peak value, and the potential through this capacitor Vc2 is equal to 2Vm. Now in the next positive half cycle, we have the same situation here. Like in the next positive half cycle, we have capacitor C1, here we have diode D1, here we have capacitor C2, and here we have diode D2, and here we have capacitor C3, and here we have diode D3. This is D1, this is D2, this is D3. Now this is capacitor C1, this is C2, and this is C3. C1 is charged to its maximum value, and the voltage across this one is Vm. C2 is also charged to its maximum value, and the voltage through this capacitor Vc2 is also 2Vm. Now during the next positive half cycle, like in the first positive half cycle, this capacitor charged to its maximum value. In the negative half cycle, this capacitor C2 charged to its maximum value. Now in the next positive half cycle, this cycle, what will happen? This has become positive, this will become negative. Diode D1 and D3, they are forward bias, while diode D2 is reverse biased. So they act like this D1 and D3 act like a short circuit, and this D2 act like a open circuit. Now we have the circuit diagram here, which I plotted again. We have capacitor C1, we have diode D1, which is short circuited, we have capacitor C2, and we have diode D2, which is open circuited, and we have capacitor C3, and we have diode D3, which is short circuited. So this is D1, D2, this is D3. Now this is C1, this is C2. This charge to potential is Vm, and this is Vc2 is also 2V. Now this is positive, this is negative. Here we have, if this is positive, this will be positive, this will be negative, and this will be positive, this will be negative, this will be positive, this will be negative. Now the current flow from positive to negative terminal in this way. So apply Kirchhoff law to this loop, and I am starting from this point. So we are moving from positive to negative, like from higher to lower. So we have minus V. Now I am starting from this point, yes, from lower to higher, from lower to higher. So we have plus Vm, and then we move from here to here. We are moving from higher to lower, so we have minus V, and then we are going here, and this is capacitor C3, and voltage across this is, I call it Vc3. So we have minus Vc3, and then we reach here, and we are moving from lower to higher. So here we have voltage which is 2Vm, so plus 2V, which is equal to 0. Now this Vm cancel with this Vm, so Vc3 is equal to 2V. Now after the completion of the 3 half cycle, like the first positive, first negative, and the next positive half cycle, all the capacitors C1, C2, C3, they get charged to its maximum value. C1 gets to a charge to its maximum value, and the potential through this capacitor is now Vm. C2 get charged to its maximum value during the first negative half cycle, and the potential through this capacitor is now 2Vm. And C3 get charged to its maximum value during the next positive half cycle, this positive half cycle, and the potential through this capacitor is Vc3, which is 2Va. Now apply after this second positive half cycle, apply the load resistance. So we have the situation now, this one. Here we have capacitor C1, here we have diode D1. Here we have capacitor C2, here we have diode D2. Here we have capacitor C3, and here we have diode D3. This is diode D1, this is diode D2, and this is diode D3. So after this cycle, 2 positive and 1 negative, we have C1 is fully charged, C2 is also fully charged, and C3 also fully charged. The potential voltage across this capacitor Vc2 is 2Vm. The voltage across this capacitor Vc1 is Vm, and the voltage across this capacitor Vc3 is Vm. Now applied load resistance to this point, these 2 points. After this first 3 half cycle, apply the load resistance here, and the voltage drop across this load resistance, I call it output voltage, which will be equal to V output or V naught, which will be equal to the voltage of capacitor C1, which is Vm or Vc1, and the voltage of capacitor C3, which is Vc3. Now Vc1 is Vm and Vc3 is 2Vm. So it means that the output voltage of this voltage tripler V output is 3 times the voltage appear on this secondary coil. Here we have the voltage appear is always V. So it means that this voltage tripler increase the voltage 3 times as compared to the voltage applied to the secondary coil or to the input voltage. So this is called voltage tripler. So I will send you the notes of voltage quadrupole. It's very simple, same like what we did before. I can explain it through the notes, by using my notes, not by writing on this paper. Thank you. In the next video.